Navigating the data center site selection process and developing infrastructure projects can be very complicated and often politically driven. Welcome to Internet Infrastructure Issues, Data Centers 101. This afternoon, in the second of our installments, we will cover water footprint and consumption. The McGuireWoods team has more than a decade of success in helping our clients achieve their business and infrastructure goals, most especially in the area of data centers. Our lawyers have experience in real estate, incentives, tax, litigation, data privacy, and information security. With offices in key markets including San Francisco, Los Angeles, Atlanta, Chicago, Charlotte, Houston, Dallas, New York, and Washington, we bring the firm's collective resources of more than 1,000 lawyers, complemented by a top-flight consulting group, McGuireWoods Consulting, to bear whatever our clients need in their business. Our team offers sophisticated counsel to clients at every stage on all sides of data center and internet infrastructure development. This afternoon, as we address water footprint and consumption, I'm pleased to introduce Walter LeClaire. Walter is the Director of Environmental Occupational Health and Safety for Digital Realty Trust, and most importantly, in 2018, led an effort to have Digital Realty Trust recognized as America's safest companies as presented by EH&S Today magazine. I'm also joined by Michael Abradovich, Esquire. Michael is an attorney, but most currently he's an innovative executive with a background in global marketing, sales, and sustainability in varied market segments, accustomed to driving growth, productivity through technology, people development, and engagement. As we address our focus this afternoon on water, I'd like to turn the presentation over to Walter and then to Michael. We will also be joined today by Greg Regal. Greg is a land use attorney who focuses on data centers in the Northern Virginia region, the epicenter of data center development, as well as across the entire United States. We're joined by Tracy Baynard. Tracy is with McGuireWoods Consulting and focuses her practice on development of internet infrastructure. We're also joined by John Lane, and one of our speakers today will be Jonathan Rock. Jonathan most notably represents water and wastewater authorities, specifically in the Commonwealth, but also across the country. And Preston Bryant, my good friend with McGuireWoods Consulting. Without further introduction, I'd like to turn the presentation over to our special guests, Walter LeClaire and Michael Abradovich.
Thank you, Dale. Thank you, everyone, for joining here today. Walter will advance here to this first slide for us here. In the next couple of slides here this morning, my goal is to set the stage for water use in industry as a whole, and largely with a focus on the data center segment, obviously. We're going to share some tools that organizations are availing themselves of as part of their water stewardship efforts, and set the stage for Walter, who will provide some real-life examples of the great work that Digital Realty is doing on this front. Now, to start, one of the drivers as it pertains to industry's growing focus on water is that it's becoming very apparent that global water scarcity is a real thing. Many organizations are currently operating in regions that are under significant water stress, and as these organizations continue to grow to meet consumer demand, just like data centers, they'll continue to expand into other stressed regions. From a data center perspective, this includes many of the targeted emerging markets. Therefore, addressing these constraints and the potential impact to operations is really becoming more of a business necessity. Walter, as you advance, please. So from a challenge perspective, we already know that there's significant water scarcity issues in many parts of the world. But from an industry perspective, the future outlook on the demand of fresh water supplies is only going to become more challenging due to factors that are on this slide here. Specifically, we're slated to have about 50% more people inhabiting the Earth by 2050. There's going to be 4 billion more consumers in cities by 2025. a 2.5 times greater demand of water per capita than in rural areas, and probably more troubling, demand for fresh water that's anticipated to exceed supply by 40% within the next 2 decades. To this extent, according to the Organization for Economic Cooperation and Development's Environmental Outlook to 2030 report, 47% of the global population will be living in areas of high water stress by 2030. Walter, next slide, please. So in addition to the real challenges with water scarcity, there are additional water trends and challenges which global organizations face. These are things like increasing regulations, stricter water policies in many regions, tighter water quality requirements, both of which posing financial implications to industry, growing public pressure through things like the UN Sustainable Development Goals, and increasing awareness from the public as a whole. In the data center segment, there are a couple of instances where growing public awareness has already posed some challenges from a developmental perspective. Rising investor disclosure. Investors are becoming increasingly interested as to how organizations are working towards insulating themselves from risks posed by limited natural resources. And then lastly, a shift to supply chain water risks. Really a lack of a clear picture as to the risk exposure water scarcity can pose to business operations. Walter, next slide. So to compound the issue, there's historically been a lack of understanding on the full value that water has on operations. So perceptions have been, and for many they still are, that water is cheap and it's readily accessible based on the cost seen for water and sewer. In reality, all the water on the planet, only 3% is fresh water. And of that 3%, 1% to 2% is locked up in polar ice caps. So leaving obviously very limited fresh water that is accessible for human consumption. So obviously, one of the problems with basing water's value on its incoming and discharge costs only is that it fails to really reflect the full value of water, which includes some of the additional costs reflected on this slide, and largely due to the limited view for many organizations of water really being a material business asset. So Walter, next slide. So as noted in the prior slide, one of the historic beliefs is that water is cheap and readily available. And one of the biggest culprits of that belief is that water on the whole is really undervalued, and it still is, with pricing really being inverse to risk in many regions. Obviously, there's a societal element to this, which is a larger conversation for another day with respect to an individual's accessibility to a basic human need. But still, this is one of the largest challenges in really addressing water stewardship and water scarcity. Next slide, Walter. To compound water largely being undervalued is the fact that the largest and fastest growing economies are in these regions, the regions where we have the fastest and largest growing economies are also regions where we face increasing water risk. Now, water scarcity is just not limited to desert regions or remote areas. Most of the world's largest and most populated economies face water scarcity risk and constraints to growth. To give you an example, here in the U.S. and California, where I live, it's pretty well known that extreme drought over the last decades has been pretty impactful. California is the 7th largest economy in the world, and researchers have estimated that the drought conditions have cost California $2.2 billion and almost 20,000 jobs. So a clear illustration of the impact water scarcity can have on a major economy. Next slide, Walter. Now, when we talk about water scarcity, I think it's really important to more clearly define what it is we're referring to. When we refer to water scarcity, we're really talking about a function of water quality and water quantity. Quantity from the standpoint that is noted in the prior slide, that the fastest growing regions are often suffering from a rapid decrease in fresh water and quality from the standpoint of challenges created as a result of the combination of diminishing freshwater resources and challenges with managing current water discharge. Ultimately, for most global industries, including data centers, water scarcity equates to business risk in terms of potential for operational disruption. A perfect example being how water scarcity has resulted in the closure of roughly 20 Coca-Cola bottling plants in India in the last decade. Next slide, Walter. Now, because water is essential to the production and delivery of virtually all goods and services, global industry faces water-related challenges that make increasing demand difficult. Things like variable water quality, complex chemistries that are often needed to treat this water, changing regulation like those that we discussed a little bit earlier, complex connections across the value chain, reputational challenges like those touched on a little bit earlier, and also one that Walter is going to speak on in more depth on how Digital Realty is addressing the health and safety concerns water poses from a waterborne pathogen perspective. Next slide, Walter. Now, this is not to say that these growing water challenges have not been met without any response from global industry. In fact, as you can see here on this slide, the number of organizations that are setting water targets and are reporting on water risk continues to grow. However, despite the growing target setting and reporting on water risk, we're really not seeing a measurable impact on water use. In fact, from a global perspective, data is actually showing that we're seeing an increase in water use by industry. So now, one of the reasons there's this apparent divergence we submit is that there's an execution gap between corporate goal setting, risk management, and ideologies with the ability to deliver on them from a local or facility or plant level. Now, this execution gap, if you will, can be due to a number of reasons, ranging from things like lack of tools or resources to execute on these goals from a local facility or plant manager perspective, to not possessing accurate metrics required to justify capital projects which would support and further these corporate goals and objectives. So the natural question that follows is how can we support industry and the data center market space to close that execution gap and be better positioned to attain corporate water goals and actually drive down fresh water consumption. In these next couple of slides, I'm going to share a couple of free tools that Ecolab has created, some in partnerships with organizations like Microsoft and TrueCost that are designed to support in the closing of that execution gap. And Walter, later in this presentation, will speak more directly to how Digital Realty has leveraged these tools as part of their own global water strategy. The first tool that I'm going to talk about is the Water Risk Monetizer, which was first introduced in 2014 and is designed to help industry water users better understand and quantify water-related business risks, both now and forward-looking. The tool leverages data from sources like TrueCost and the Aqueduct Water Risk Atlas to provide organizations a risk-adjusted water price that represents the full value of water, which we discussed a little bit earlier, to an organization based on the local watershed's demands and scarcity. The ultimate deliverable for these organizations being insights that can allow them to take action now to reduce freshwater use and factor in water scarcity into their decisions to support business growth. So, to provide some additional details and insights derived from Water Risk Monetizer, the tool takes into consideration data pertaining to local watershed incoming water risk, looking at things like the amount and quantity of water available in a specific watershed, the amount of water used by a facility, additional demands on the supply of water, and the impact of a facility's water use on the local water basin, as well as outgoing water risks, things like the amount and quality of the water being discharged by a facility, local water quality thresholds, and the impact of water pollution on the local water basin. And this is designed to help organizations evaluate potential revenue at risk associated with water availability in the various regions in which they operate. The output is actionable information which organizations can use to better make these informed business decisions. As one can imagine, this is extremely valuable for industries like the data center market, as it provides insights as to risk-adjusted water prices, both now and forward-looking, that can be used for budgeting, planning, strategy development, and design for future expansion, again, especially in those targeted emerging markets. So with that said, I'm going to now turn this over
Michael,
to Jonathan.
this is Dale.
Yep.
Before we go to Jonathan, give Jonathan a chance to prepare, a question from the listeners. Where are these tools available and what is the cost?
Great question. Thanks, Dale. These tools are free tools provided by Ecolab. They can be found online. The Water Risk Monetizer can be found at www.waterriskmonetizer.com, all one word. And the Smart Water Navigator, which I'll speak to in a little bit, can similarly be found at www.smartwaternavigator.com.
Thank you, Michael. I also want to remind the listeners that at the bottom of your viewing screen, you'll see a question and answer button. If you have questions, please feel free to log in with those, and we'll make sure to address them as they come or at the end of the presentation. We've reserved some time at the end of this presentation for that very purpose. Jonathan Rock, thanks for joining us today.
Thank you, Dale, and thanks to Michael for a very good overview of some of the issues of water risks globally. We wanted to start bringing it down a little bit more into focus for the data center industry. And I'll begin my presentation by stating what's probably obvious to many on the webinar, which is that water is a critical need for data centers, particularly those which use water for cooling. Data centers, as Walter will probably get into in more detail, generate a lot of heat from the computing operations, and that heat needs to be dispersed and cooled. And so water becomes a critical need for many of the data centers in order to operate. I'm speaking today as both a lawyer who represents data centers on permitting and zoning issues in their development, and also, as Dale mentioned, as a general counsel of Loudoun Water, which is a public authority that supplies the water and sewer needs in Loudoun County, Virginia, which is one of the concentrations of data centers in the U.S. For my presentation, I'm assuming that the data centers have some choices for cooling. Some use air, some use water, and Walter's going to get into some further detail about that. And I'm also assuming that there are choices available as you're developing a data center for water supply. There are some areas of the country where there really aren't many choices. You may be restricted to one particular source of water supply. When looking at developing a data center, you want to make sure that you look at the life cycle costs of the potential alternative water sources. And those life cycle costs should include both the initial capital costs, such as construction, connection fees, and permitting, but also an analysis of the annual operating costs for each of the potential systems. For capital costs, the construction is something that you obviously can obtain from a contractor. The connection fees are often quite substantial, in some cases running into the millions of dollars for connection to municipal water supplies. And the reason those connection fees tend to run so high is that as you connect to that system, you're not only paying for the actual physical connection, but you're also paying for the pro rata share of all of the infrastructure necessary to collect and bring that and treat that water and bring it to your particular location. The annual operating costs can vary quite significantly between the different types of systems because if you may save costs on the initial capital investment but have to replace equipment more frequently for certain types of water supply. As you are looking at different sources of water supply, it's probably important to have some conversations with the suppliers, the public water utilities, and unless they are investor-owned utilities that are not part of the governmental system, those water suppliers are probably subject to Freedom of Information Act requirements in each of the states. And for some data centers, particularly that have high security clients, it's important to not disclose a lot of information about the operations of that center. And so a concern is that if you provide projections in terms of water use that are sensitive for security reasons and other reasons, those projections may be subject to disclosure upon a public request under the Freedom of Information Act. There are some exclusions that are available depending on what state you're located in, but you should just know before you start providing that information exactly what the rules are for potential public disclosure. As you're researching alternative water sources, to my knowledge, there are essentially 4 different types of sources that might be available to a new data center development. First, and probably most common, is the standard potable water supply from a central water system, water utility. This is water that's been treated for drinking water purposes and then distributed through a system of mains to the location where it's consumed. The second alternative is well water, where you would install or utilize existing wells on your site or near your site to draw the water from groundwater aquifers, and then there may be some needs to treat that water before it's used, particularly for cooling purposes, but in general, depending on the quality of that water, it's readily available for use in a cooling system. Third alternative would be raw water, water withdrawn directly from rivers or streams in the vicinity of your location. Typically, raw water requires a greater level of treatment, both to deal with turbidity issues as well as chemical constituents, as well as disinfection. So there's a lot of investment that's needed in order to utilize raw water. And then finally, a source which is emerging as a greater source, particularly in Loudoun County, is the use of reclaimed water from a local wastewater treatment plant. In many locations, the wastewater treatment plants are required to treat the sewage water to a level of quality that approaches drinking water. And normally that's just discharged into a stream or river, but it can be diverted, as it is in Loudoun, and distributed to customers who can use it for industrial applications as well as irrigation applications and other non-drinking water applications. It's sometimes referred to as purple pipe water because it's distributed through purple pipes to identify it as something, as a different source. One of the advantages of reclaimed water is that it often is priced very favorably. In Loudoun County, for example, instead of paying $3.50 per 1,000 gallon of potable water, you can pay $1.61 or less than half of the potable water rate for reclaimed water. Another significant advantage is, again, in Loudoun, the connection charge, the availability charge for connecting to the potable water system is $13 per gallon per day of estimated usage, which can be a considerable charge, whereas you only have to pay 10% of that charge if you were to use reclaimed water. So some real advantages to the use of reclaimed water if that's available to you. The other issues to consider before making a selection of water source for a data center are to look at long-term reliability and cost of that water supply. Obviously, we're all aware of the impacts of climate change that have already begun to affect many areas of the country. Those can have significant impacts predicted into the future in terms of the quantity of water that's available coming from different sources, and it also can affect water quality that can affect costs. So need to factor that in terms of your selection of water supply. There also may be consumptive use restrictions in the particular location that you're developing the data center. This slide shows a photograph or a graphic of the water cycle. Obviously, we're all familiar with the basic water cycle, but there is also a water cycle within municipal systems where water is collected typically from a lake or river, treated, circulated to the customers who use it, and then put it back into the sewage system where it's treated, and then returned to the lakes or rivers where it was withdrawn from. And the use of water for cooling systems in data centers can actually divert water from that cycle because it gets utilized particularly for evaporation, goes up into the air, and may not return in the same quantities to the water bodies where the water is being withdrawn from. So some states in particular are looking at restrictions on consumptive use where a user of water isn't returning it back into the same water supply or aquifer, and restricting those withdrawals that are used for consumptive use, such as data centers. In addition, states are also enacting certain water withdrawal regulations on surface and groundwater in many locations where the amounts of water that are withdrawn are limited in order to maintain a safe supply both for other customers and also for the downstream aquatic environment in many locations. So there are lots of concerns to look at before you make that selection of an appropriate water supply, but there are consultants and tools and water providers who can help you with the information needed to do that. I'll conclude my presentation there and turn it over to Walter.
I'll take over here, Jonathan. Thank you. Very, very good section here on water source selection here, especially in the design phase. So now this next slide is by no means an exhaustive review of all cooling technology available, and I'm not going to get too far into detail of it, but I'd rather provide a high-level overview, as cooling tower design has really been an area where there's been a considerable amount of innovation as of late. For data centers, HVAC design selections have largely focused on the solution that's going to yield the most energy efficient data center given its specific location. Now, historically, there's been two routes organizations have gone, specifically air-cooled or water-cooled equipment. From a comparison standpoint, efficiencies for water-cooled application often provide for enhanced energy efficiency compared to air-cooled applications, especially in your larger hyperscale or enterprise data centers. Now, this is not to say that air-cooled solutions have not been leveraged successfully, especially for data centers in more temperate or non-humid climates. So to this extent, when we talk about water scarcity, the initial knee-jerk reaction may be to select the air-cooled application from a design perspective to reduce on-site water consumption altogether. However, such a selection, such a motivation really fails to take into consideration the concept of the energy-water nexus, the idea that water is needed to create energy and energy to create water, which, again, a broader topic for another conversation. So when we factor in that energy-water nexus, selection of an air-cooled application could, from a holistic perspective, potentially result in an overall hydro footprint of a data center that's greater than one that utilizes water for cooling. Obviously, this is location dependent and requires considerable efficiency evaluation of these solutions. But as of late, there's been a growing popularity with what I'll call some hybrid solutions, if you will, which leverage the advantages of both air and water cooling for lack of a more technical description. These solutions include direct evaporative cooling, indirect evaporative cooling, indirect direct evaporative cooling, etc. And these types of cooling technologies are those that you'll see manufactured by firms like Nortech, Munters, Vertiv, just to name a few. It's by no means an exhaustive list there. So the takeaway here is that in addition to water source selection, there are a host of cooling technology options that also need to be considered and evaluated at the data center design stage as well. Now, this is my last slide before turning it over to Walter to share more about the Digital Realty's water stewardship journey. We've touched on the idea of water scarcity challenges and a tool that can better help industry assess risk. Jonathan spoke about water source considerations at the design stage, and similarly, just touched on this cooling technology design considerations as well. There's one additional free tool that industry can leverage to close that execution gap that we spoke about earlier. That tool is the Smart Water Navigator, which is really designed in large part to help bridge that execution gap between the good intentions and goals of an organization and the ability of local facilities and plants to support in achieving those goals. The tool provides greater granularity and visibility as to where each specific facility, plant, or data center lies on what's called a water maturity curve. And it also provides industry-specific actions, tools, and resources to allow steps to be taken at a local level to advance water stewardship practices and progress that location along the water maturity curve. From a corporate overview perspective, organizations have visibility as to how each one of those locations compare to each other and where opportunities lie for improvement. So with that, I'll transition over to Walter so he can discuss in greater detail the steps that Digital Realty has taken in building in resiliency and redundancy with respect to water use at their data centers as part of their global water strategy.
Yeah, thanks. Great information, the three of you, Dale, Jonathan, and Mike. That was fantastic. So I'm going to, as Mike said, I'm going to take what has been presented and pull the string on it. I'm going to give you a real-life example of how a company has taken the water scarcity issue seriously, and we've used the tools that have been talked about here. So I'm going to share also about a little journey we took and where we are in that journey. So starting 2 years ago, we began having conversations about the role that water plays in our operations and what we can do to building greater resiliency and redundancy. In response, last year we created a formal global water strategy, policy, and plan. One of our drivers for focusing on water was the agreement within our organization that this global water scarcity issue is a real thing. As you've heard, water demand will soon outstrip supply. And as a global organization, Digital Realty currently operates in regions that are under water stress. And as we continue to grow, we'll likely expand into other stressed regions. There are also other motivations, other reasons for us doing this. Water is an essential element to the operation of a large number of our data centers. It is widely used due to its heat transfer properties that make it a great solution for efficient design in many regions of data centers. Water scarcity and water quality issues can have an extremely negative impact on our operations if not managed or addressed properly. It can increase life cycle replacement costs, reduce efficiencies, and negatively impact TCO if managed poorly. We use large volumes for cooling applications, and finally, we have a desire to have water practices more unified globally and based on local challenges. So our ambition, our vision, our mission, pick your term, is the development of an integrated water management strategy that reduces our global hydro footprint while ensuring reliable performance and operational resiliency for our data centers. When we made the decision that we were going to focus on water, we first brainstormed, what is it we were looking to get out of this endeavor? Simply, what was our end game? What we came up with were several objectives. Enhance visibility. having a better handle of where, how, and how much water we are using at our data centers, improve awareness to provide greater understanding as to the magnitude of water we use across the enterprise, increase resiliency and redundancy. We wanted to implement strategies to allow us to better respond to growing water scarcity issues and quality issues that we were seeing. And finally, to better monitor and measure our global hydro footprint. This stems from the idea that you can only manage what you measure. We believe this can be achieved through the use of better tracking and trending of water usage through dashboards, which I'll show you in a little bit here. With the objectives in mind, our next step was to figure out what our corporate water strategy would look like. We used these 6 attributes of a successful corporate water strategy to guide our discussions in crafting what our strategy would look like at Digital Realty. First, assuring that any program would align with our business objectives as well as work with our sustainability efforts going on. At its backbone, addresses the impact that water has on our business. And although this strategy is global with our water sites, the strategy is executed at the site level to address regional specific water risks. This allows for better collaboration and engagement of the local teams towards common water use optimization goals. We wanted solutions identified that coincide with the regional specific challenges and constraints, and ultimately the end result should be a mitigation of risk to our business. Using those principles as a guide, we crafted from our perspective what would the elements of this corporate water strategy look like. And this is what we came up with. It was our current state evaluation across enterprise. We wanted to map and evaluate water use practices at a local level, prioritize location hotspots, improve water use practices, and enhance optics to drive the reliability and resiliency. The initial step was essentially documenting where we were in our stewardship journey down to the granularity at the site level. It entailed performing site surveys of all of our data centers globally that utilize water for cooling, where, how much we are currently using, or by contrast, whether we have this information already available. During these surveys, we confirmed operational details. We're talking about design tonnages, actual annualized operating tonnages, flow rates, system volumes. We identified the extent to which appropriate submetering was in place, or in some cases wasn't in place. And lastly, we determined what our water would look like at the local level. As part of these surveys, we also did laboratory sampling. We wanted to check to model prospective programs for each of our prospective data centers to determine options available for them to move forward with. In all, this was a heavy, heavy lift. It was strategic and educational for all of Digital Realty from top to bottom. Okay, so with the information and data collected, we leveraged the Smart Water Navigator, and that's the free tool Michael was talking about. There were different tools available inside that tool, which I want to just highlight a little here. There were checklists that were available. There was also some goals and specific actions that could be taken by the local teams to improve where they are on their water management journey. So the next thing we did is once we had that baseline is we took the data and information gathered during the surveys and plugged it into the water risk monetizer that Mike will talk about. Again, this is a free tool that Ecolab provides. They developed it with Microsoft and TrueCost. Through this use of this tool, we've been able to put together an initial prioritization matrix, which you can see here. It shows, based on our growth potential for sites and regions with high scarcity, which sites we should prioritize our focus on with regards to the corporate water strategy. It should be noted that we can filter this data in a couple ways. First, we can filter the data to show us which regions, geographies pose the greatest risk to our operations. And then secondly, overlaying this data with the annual water use and planned growth for a site, we can create a list that outlines which sites we should be focusing on first. So it's quite a tool we've used, and we definitely have it. You can just see different sites are in different regions based on it, and it helps us focus on where we want to address our efforts and our money. Okay, improved. After finalizing our prioritization of the region of sites, the focus shifted to projects or solutions that can be implemented to mitigate water risk. Again, going back to our laboratory sampling and original site surveys, we modeled various potential treatment strategies with each of the available water qualities to determine appropriate paths. The three solutions are reduce, which is this could involve projects like tweaking a treatment program, approaches, chemistry, implementation of pretreatment to reduce current consumptions, or transitioning to non-potable water sources for the water use of our cooling equipment. It's something Jonathan was just mentioning. Reuse. These projects involve determining whether there's a discharge water from other processes on site that can be captured, collected, and used as makeup water for our cooling systems, and then recycling. These projects are projects like cooling tower blowdown, capture, treatment and plumbing back as makeup water feed for our cooling systems, ostensibly creating a zero discharge facility. The last piece is the financial component. To get anything going, you got to have the money available, and we needed to put together the project, the business case for these projects. And this is what I want to share in general terms with you. This is an example of one of our reduce projects. We are replumbing the makeup water to the cooling tower with reclaimed water. This is a data center in Northern California. This has financial benefits, as you can see at the bottom, but more importantly, we'll be taking 16+ million gallons of potable water off that shed and using reclaimed water instead. So we're doing something great for our watershed in the Silicon Valley, and this is the project that's going on currently. Okay, changing course a little. Years ago, we put into place a water safety plan to protect from Legionella and other waterborne pathogens. In short, it consists of annual online disinfections, semi-annual offline tower cleaning and disinfections, quarterly Legionella testing, and we do independent tower inspections and certifications in North America. Obviously, costs come into play in addition to regional issues such as New York, New Jersey, where there are stringent requirements in this area. This is actually a whole webinar in itself, so I'm going to move on. Get us to the enhancing metrics. For this strategy to be one that is sustainable and continues to evolve, we needed to have enhanced visibility, measurement, and monitoring of our water use across our enterprise. From our perspective, the way we were going to do this is achieved through digital roll-up of information. Here are examples of what we envision. This part we are in the process of implementing. This is what we envision our digital dashboards to look like. That will help us track and trend water usage at our data centers, compare water usages across sites given their respective loads, and quantify savings associated with identified and implemented water projects. This all said, these dashboards are only as good as the information you put into it, right? So to try and streamline this process and improve accuracy, we're looking at different technologies, sensor technologies, water flow technologies that will help push us to have these dashboards be accurate and valuable to our teams. Okay, so just to finalize up here, we were looking for a formalized, evolving, and living corporate water strategy that outlines how water is to be managed, as well as the details of projects and impacts across our data centers, which we can budget for and act upon. So we were looking for something real. A greater understanding is the regions that water possess the greatest risk and how to approach water-related operations in those regions. We were looking for water details that can be shared with our design and construction team and incorporated into future build strategies and emerging market considerations. This goes back to the Q&A session from 2 weeks ago in our initial webinar. We talked about energy concerns, staff availability, and water was another consideration I mentioned, because we do take into account water when building our data centers. And finally, future potential to pursue local watershed projects to achieve a net zero use impact. Well, so that's what you have in about 45 minutes there. We presented you with the big picture and brought you down to the ground level with a real life example for the water scarcity, quality, and use. I hope you found it valuable. We're glad to take any questions, and I'm going to transfer this back over to Dale.
Thank you, Walter. I'd like to shift focus for just a second and ask Walter, Michael, Jonathan, as we look out at the future of data centers, one of the trends that we see is the need for and development of smaller and faster data center components. And usually when you make these kinds of technologies smaller and you make them faster, you necessarily make them hotter, and that requires more cooling. And so, Michael, I'll start with you and ask first, what do you see currently as the most commonly seen cooling technology? What do you see in recent trends, and what does the future hold for data center cooling and water?
Thanks, Dale. It's a great question. As you know, as things like Internet of Things and artificial intelligence continues to evolve and grow, we're going to be increasingly shifting to a more dense, if you will, data center environment where greater computing power is going to be required, which in turn is going to be creating additional heat. Currently, it is a bit of a mixed bag, I must say. It varies depending on the region, everything from water-cooled applications to air-cooled applications, and also those that combine the two, those hybrid solutions. Organizations, from organization to organization in the data center space, have their own beliefs. Some are transitioning as they look forward to a more air-cooled basis of cooling, while others are implementing solutions that allow for water-cooled technologies to be leveraged, but in 3 different forms to try to optimize energy use, specifically implementing water-cooled technologies that allow for mechanical cooling operation, free cooling where local climates permit, or partial free cooling through use of plate and frame heat exchangers as well. So as we look towards the future, obviously with greater heat and greater density, we may see a shift back from air-cooled to more fluid-cooled applications, especially as we see some of these more technologies about immersion cooling and cooling down to the chip level and rack level. So as the density increases, I think we may see a little bit of a shift back towards liquid cooling, be it water or another type of fluid.
Thanks, Michael. What do you see, Walter, in the future for data center water use and new technologies? What do you see as the most promising new technologies or something that we can look forward to?
Yeah, thanks, Dale. As far as I'm going to do this in 2 pieces. From an EH&S perspective, I really feel like the future is about sensor technologies, and that goes from anything. So it's even broader than water. But I think as we look for the future from a water perspective, as we drive down into the water topic that we're at, I think Michael's right. We're going to see a shift towards more water cooling, especially as reclaimed water availability matures. So when you talk Loudoun County and you talk California, so those two examples, we all know what purple pipe is. We're all using it for the most part, general terms. But as other parts of the country and the world start to get availability to reclaim water, you're going to see a shift in where water then, because, again, like Jonathan mentioned, because of the pricing of the reclaimed water, it's going to be an attractive alternative.
Thank you, Walter. Jonathan, Walter, Michael, I'd like to shift this again away from general water and cooling and more specifically to reclaimed water. And I'll start with Jonathan first. I know you've worked on several substantial water reuse projects all across Northern Virginia, which is the heart of the data center explosion in the United States. And I have a general question first, and that is, what do you see as far as trends in water reuse in the projects that you've seen? And then Jonathan and Michael and Walter, we have a specific question about encountering specific water quality issues with reclaimed water, specifically chlorides. I know copper and other metals can become issues. But Jonathan, in the water reuse projects, let's talk about that generally before we focus on constituents that might sometimes cause problems.
Sure, Dale. What I've definitely seen in the last couple of years is a convergence between the demand side of data centers needing more and more inexpensive water supply as they increase their size of these hyperscale projects, and the need from a public utility side of needing to basically get rid of their treated wastewater in a manner that doesn't put it back directly into streams because of nutrient limits that are being applied to Chesapeake Bay in particular in this area. So it's definitely a very mutually beneficial convergence of interest. The usual hurdle to get over is the capital cost of building a distribution system, separate distribution system for reclaimed water. Loudoun Water took advantage of some federal grant funding during the 2008-2009 financial crisis. And frankly, water utilities are looking for if there may be similar grant funding to help kickstart these types of projects going forward. So I'm very hopeful that you'll see an increased amount of development of reclaimed water for data centers.
Thanks, Jonathan. Walter, Michael, have you ever experienced any water quality issues in data centers specific to the use of reclaimed water, chlorides, and other constituents that would affect conductivity?
So
Walter,
let me start off. Yeah, let me just start off from a general, and then we can let Michael get into the weeds on the technical. But as the reclaimed water, as I was mentioning about where we're going, as the reclaimed water improves in quality and the whole system matures from a utility perspective, it's becoming easier for us to manage the reclaimed water. So we're seeing improvements in it. I think the question is very valid. Definitely, if you're talking 5 years ago, we were having tremendous amount of problems managing the reclaimed water. The variability was a problem. The amount of other components in there, the impurities was a problem. But we've actually seen the improvement going forward, and that's why I think the reclaimed water is more the future. I'll pass this over to Michael so we can get into the chlorides issue and things like that to really drive down on that question.
Yeah, and to not get into great a detail from a technical perspective. So obviously, I think as Walter mentioned a little bit earlier, there's various reclaimed municipalities that are at various stages in their maturity, if you will, of their manufactured product, and essentially that's what reclaimed water is. And then different municipalities have different quality reclaimed water. Some reclaimed water, for example, in Santa Clara, the manufactured reclaimed water is actually of better quality than the industrial or potable water quality, believe it or not. and so it promotes for more optimized use in terms of overall water usage on an annualized basis. There are some areas where chlorides are a concern, both in reclaimed and in potable or industrial waters as well. I think of Chandler, Arizona, where some of the potable water there also has chloride as a limiting constituent in terms of corrosion on assets, and chloride control is very important, associated in addition to control of all other constituents that can either impact assets from a corrosion or reduction in heat transfer efficiency perspective. So when we look at managing those constituents, we really have to take a mechanical, operational, and chemical approach, figuring out what type of equipment potentially from a pre-treatment perspective could address chloride concerns, what from an operational standpoint, from a enhanced chemical treatment control platform can support with managing those challenges. And then from a chemistry standpoint, making sure that we have a robust chemical program that aligns with the specific challenges for that specific water source.
Walter? Jonathan, anything to add?
No, I think that was pretty. I think we nailed that one.
We're running up against our time. As always, it's been a really informative hour to spend together. I appreciate the questions that we received. It's always a pleasure to discuss internet infrastructure issues, specifically data centers. I'd like to invite everyone who's listening to our next webinar that will occur on Wednesday, May the 20th, and look for future announcements with that. Thanks again to everyone who helped organize this, to McGuireWoods, also to Walter LeClaire, to Michael Abradovich, Jonathan Rock, Gregory Regal, Tracy Baynard, John Lane, and Preston Bryant. Until next time,